Somewhere in the Valley of the Kings, sealed inside a pottery vessel buried alongside a pharaoh, excavators found something that stopped them cold. Tucked among the gold masks and alabaster canopic jars was a substance still amber, still viscous, after more than 3,000 years in the dark. The grain in the tomb had crumbled. The dried fruit had collapsed into dust. The floral offerings had oxidized into unrecognizable brown powder. But the honey had simply waited. 3 millennia of Egyptian summers, of dynasties rising and collapsing above it, of the entire Roman Empire rising and falling, and the honey sat there, unchanged, as though time had agreed to leave it alone. Now, whether that honey was still edible after 3,000 years in a clay jar is a question historians argue about. The chemistry says it is possible. The documented finds are real. But the famous stories of excavators tasting ancient honey and finding it sweet belong more to popular legend than to the excavation record. And that distinction matters, because the truth of what honey actually does is more interesting than the myth. Think about what the chemistry means. Every other food on Earth follows the same story. It is made, it is eaten, or it rots. Bread goes stale in days. Meat decays in hours without refrigeration. Even salt-cured provisions from ancient Rome would not survive 3,000 years sealed in a clay jar. But honey outlasted all of it. How? That question sat unanswered for most of human history. Civilizations that used honey daily, that built economies around it, that offered it to their gods and packed it into tombs alongside their dead kings, never once understood the mechanism behind its immortality. They just knew that it lasted. But the story of honey does not begin in a pharaoh's tomb. It begins tens of thousands of years before the first pyramid was laid, in the dark of a limestone cave in Spain, with a human figure dangling from a cliff face above a drop that would kill them, reaching, through a swarm of angry bees, for something they wanted badly enough to risk everything. Honey is the oldest food on Earth that humans did not invent. We did not cultivate it, did not refine it, did not add anything to it. We just found it and decided it was worth bleeding for. This is the story of how that decision quietly shaped human evolution, built and funded some of the greatest civilizations in history, baffled every great scientific mind for 2,000 years, and left something sitting in your kitchen right now that is, chemically speaking, nearly impossible to destroy. Egyptian burial contexts preserve honey repeatedly across more than a century of excavation. Sealed pottery vessels, inscribed with hieratic marks strongly associated with Lower Egypt and royal titulary, identified their contents as honey. These finds are spread across multiple excavations, multiple sites, multiple dynasties. The consistency is not coincidence, and the question that ought to follow is simple. Why? Why did people who had access to grain, to dried fish, to salted meats, to the most sophisticated food preservation technology of the ancient world, why did they choose honey as the one food worthy of eternity? The answer is because they had already watched it survive things that nothing else survived. They had seen the evidence with their own eyes. Jars of honey opened after years in storage, still good. They did not need a chemistry laboratory to recognize that honey operated by different rules than everything else. And that recognition, made independently by people across dozens of civilizations, separated by thousands of miles and thousands of years, is the thing that makes honey's history unlike the history of any other food. This is not a story about a crop that spread because it was easy to grow, or a spice that became valuable because it was rare. This is a story about a substance that seemed, to everyone who encountered it, to refuse the ordinary fate of ordinary things. The question is why? And getting to that answer requires starting not in Egypt, not in any civilization at all, but in a moment before civilization existed, when a human being looked at a hole in a cliff face, heard the sound of 10,000 bees inside it, and climbed toward it anyway. On a limestone wall inside a cave near the town of Bicorp in Valencia, Spain, there is a painting. It shows a human figure, small, outlined in dark ochre against pale rock, suspended from what appear to be ropes or vines attached to the face of a cliff. Around the figure, scattered across the wall in chaotic curves, are bees. Dozens of them, and in the figure's outstretched hand is a basket. They are reaching into a hole in the cliff, into what is clearly a wild hive, while the bees swarm around them. The painting at Cueva de la Araña, the Cave of the Spider, is part of a UNESCO World Heritage rock art landscape. It is roughly 8,000 years old. That means this scene of a human being climbing toward a beehive predates Stonehenge by more than 3,000 years. It predates the earliest Egyptian hieroglyphs by nearly 4,000 years. The person who painted this had no writing, no metal tools, no pottery, no permanent settlement of any kind. And yet they painted this, not a hunt, not a battle, a honey harvest. The figure is not depicted as heroic or divine, just a person doing a job that was clearly worth recording. That is what makes it remarkable. Similar scenes of honey harvest have been documented in rock art from sub-Saharan Africa and from the Indian subcontinent. These were not connected cultures. They had no contact with each other, no shared tradition. They all just found honey and decided it was worth painting on stone walls, worth climbing for, worth being stung for, dozens of times, sometimes hundreds of times, in a single harvest. The wild bee colonies that early humans targeted were not gentle. Modern researchers who have worked with traditional honey hunters in Africa and South Asia, particularly with the Hadza of Tanzania and the Gurung of Nepal, both communities that maintained honey hunting traditions into the modern era, describe harvests where a single person might absorb 300 or 400 stings in a session. Gurung honey hunters still climb cliff faces on rope ladders made from bamboo, using long-handled baskets and smoking torches to pacify colonies in hives, sometimes more than 100 meters above a river gorge. The physical courage involved is not metaphorical. That is a calculated decision that something inside this hive is worth serious physical suffering. And what was worth it was this. Honey was the most concentrated, most immediately available source of energy in the natural world. Ripe fruit offered some sugar, but it was seasonal, water diluted, and available only briefly. Roots provided starch, but converting starch to usable glucose takes time and digestive effort. Honey was essentially pre-digested sugar, pure and immediate, in a package that did not spoil. A small amount delivered an enormous caloric return. For a hunter-gatherer, moving long distances between food sources, spending a significant part of a day obtaining a honeycomb was not a detour. It was a rational investment in survival. When you look at the Cueva de la Araña figure, that small ochre outline, dangling above a drop, basket outstretched into a cloud of bees, you are looking at a calculation that human beings have been making for at least 8,000 recorded years, probably far longer. The cave painter was not recording an exceptional event. They were recording something familiar enough to be worth preserving. That is how old this relationship is. Here is the thing that stops most people when they first hear it. Humans were not the only species that recognized honey's value. Across sub-Saharan Africa, a small brown bird, called the Greater Honey Guide, developed one of the most extraordinary behavioral partnerships in the natural world, built entirely around honey and built with humans. The bird cannot open a beehive on its own. Its beak is not strong enough, but it can find hives. It is exceptionally good at locating wild colonies in hollow trees and rock crevices across large stretches of landscape. And somewhere in its evolutionary history, it began seeking out humans when it found one. It produces a distinctive chattering call. Researchers describe it as a ringing, repetitive sound, unlike the bird's normal vocalizations. Then it flies a short distance toward the hive, stops, calls again, and waits. If the human follows, the bird leads them, in a series of short flights and pauses, directly to the hive. The human opens it, uses smoke to calm the bees, takes the honey, and the bird gets what it came for, the wax and the larvae left behind, which contain fats and proteins it cannot easily obtain elsewhere. A study published in Science in 2016 found that the Yao honey hunters of Mozambique had developed a specific call of their own, a trilled grunt, that reliably attracted honey guides and roughly doubled their success rate at finding hives compared with using other sounds. The birds were not responding to a generic human signal. They had learned to distinguish the specific call of cooperating humans from background noise. That is a level of learned mutual communication that researchers had not previously documented between a wild animal and humans in a foraging context. This was not trained behavior in any conventional sense. No human ever taught the bird the sequence through deliberate instruction. This is a relationship consistent with a long co-evolutionary history, one where honey-guide populations that were better at attracting human attention ate better and survived more reliably, and human populations that learned to recognize and follow honey guides found honey more efficiently. Both sides became better at their half of the partnership across many generations. The implication worth sitting with is this: honey was so reliably and consistently valuable across such a long span of time that it shaped the behavior of another species alongside our own. That is not a food being useful. That is a food being so central that it becomes a visible organizing force in the biological world around it. There is a theory, taken seriously by some researchers who study human cognitive evolution, but emphatically not a settled fact, that honey did not just sustain early human populations. It may have been one of several factors shaping the metabolic conditions that allowed for larger human brains. The human brain is the most metabolically expensive organ in the animal kingdom. Despite accounting for roughly 2% of body weight, it consumes approximately 20% of total daily caloric intake. It runs almost exclusively on glucose. Honey was one of the very few foods in the pre-agricultural world capable of delivering a dense, immediate glucose payload with no processing required. Some anthropologists have proposed that consistent, reliable access to honey, made possible by cliff climbing skills and partnerships with birds like the honey guide, may have offered metabolic advantages to certain early hominid populations over very long spans of time. Groups that accessed honey reliably had better fueled brains in the short term. Better fueled brains made better decisions. The causal chain from there to anything as large as human cognitive evolution cannot be demonstrated at this distance. It is a hypothesis built on metabolic logic, not a documented mechanism. But the basic logic is sound. Honey was among the most efficient brain fuels available to early humans in the wild, and the populations that accessed it consistently would have had a real nutritional advantage. Whether that advantage compounded into something larger is the part that remains genuinely open. What is not in question is the simpler version. For a species that needed glucose above all else, honey was extraordinary, and every civilization that came after the cliff climbers and the cave painters arrived at the same conclusion, independently. The earliest unambiguous evidence of managed beekeeping comes from Egypt, and the Egyptians did not approach it casually. A relief carving from the Sun Temple of Neyuza-Re at Abu Ghorab, dated to around 2400 BC, shows beekeepers working rows of horizontal cylindrical clay hives, blowing smoke to calm the bees, then pouring the harvested honey directly into tall storage jars. This is not wild honey collection. This is organized, deliberate, commercial apiculture. Nearly 5,000 years ago, the cylindrical clay tubes mimicked exactly the hollow logs and rock crevices where wild bees naturally nested. The bees moved in willingly, but the beekeeper could access the honey from one end while the colony continued its work at the other. Ancient sources describe apiaries loaded onto Nile barges and floated up and down the river, following the seasonal bloom of wildflowers, so the bees always had fresh pollen. This was migratory commercial beekeeping operating more than 2,000 years before the Roman Empire existed. Economically, honey functioned as a commodity in an era before coined money. Worker provisions at major sites were complex arrangements. Bread and beer were the best documented staples at places like Giza, and honey appears among the goods recorded in other contexts as part of payments and offerings, though the scale of its economic role varied considerably across different periods and sites. The medical dimension was more precisely documented. The Edwin Smith surgical papyrus, dated by scholars to around 1600 BC, records 48 injury cases with examinations, diagnoses, and recommended treatments. Honey appears among the treatments for open wounds. The physicians prescribing it had no chemical vocabulary to describe what it was doing. They had observation, and their observation was correct, for reasons the ancient world would not be able to articulate for another 3,000 years. Then there was the religious dimension. Egyptians offered jars of honey to their gods, particularly Ra and Min. The bee hieroglyph became woven directly into the formal title of the pharaoh, strongly tied to Lower Egypt's identity and the language of sovereignty. When a pharaoh died, honey was placed in the burial chamber alongside gold and lapis lazuli. They chose honey for the afterlife because they had observed that honey does not perish. They did not know why. The observation was correct. And across more than a century of excavation in Egyptian contexts, the evidence has continued to accumulate. Egypt was where honey became an institution, but the obsession spread independently across cultures, with no contact with each other, which tells you something important. This was not cultural transmission. This was every sophisticated civilization on Earth, arriving at the same conclusions through direct experience with the same substance. Travel east to ancient India. Honey appears throughout the Vedas, the oldest Sanskrit sacred texts, not as a curiosity, but as a substance woven into religious and medical life simultaneously. Ayurvedic physicians, working within a tradition whose foundational texts were being codified around 600 BC, prescribed honey for digestive disorders, respiratory infections, and wound care. Some of the specific applications: honey applied directly to infected tissue, honey used as a carrier for other therapeutic compounds, correspond closely to applications that modern wound care research has validated. In Hindu mythology, the god Vishnu was depicted as a blue bee resting on a lotus flower. These were not peripheral symbols. Honey was embedded at the foundation. Travel further east to China, and honey appears in medical texts from the Han Dynasty, recommended for fatigue and as a therapeutic agent in a tradition of practice that developed entirely independently of both Egyptian and Indian medicine. Now cross back west to Greece, where the cultural relationship with honey reached a level of intellectual intensity that approached philosophical obsession. The Greeks called honey ambrosia, divine food, the sustenance of immortality. They believed bees were sacred messengers between the human world and the gods. The oracle at Delphi's priestesses were called melissae, a word that translates directly as honeybees. Athletes competing at the ancient Olympic Games consumed honeycomb before their events as an energy source, a practice that modern sports nutrition, measuring honey's glycemic index and rapid glucose availability, has essentially validated as sound. Aristotle devoted serious observation to bee colonies. Some of his descriptions of hive behavior remain accurate today. He got some things wrong. He believed the hive's central figure was a male king rather than a female queen, an error that persisted for nearly 2,000 years. But the fact that Aristotle chose bees as a subject worth sustained scientific attention tells you how central they were to Greek intellectual life. His teacher Plato believed that the souls of orderly, law-abiding citizens were reincarnated as bees, a compliment that says as much about how Greeks regarded the hive's social organization as it does about Plato's ethics. Hippocrates, whose writings formed the foundation of Western medicine, prescribed honey for fevers, wounds, and ulcers. Later randomized trials, a Cochrane review examined the evidence, found high-quality data that honey dressings healed partial thickness burns roughly 4 to 5 days faster than conventional dressings. Hippocrates did not have access to that data. He had access to observation, and his observations held up for 2,500 years. The Romans inherited the Greek enthusiasm and scaled it into an industry. Wealthy Roman estates maintained large apiaries as a standard element of agricultural management. Virgil devoted the entire fourth book of his Georgics, written around 29 BC, to bees, describing the hive with reverence that approached religious feeling, comparing its social structure to an ideal commonwealth: disciplined, selfless, productive. Roman soldiers used honey to preserve fruit during long military campaigns. Roman cooks used it as the primary sweetener in virtually every preparation that called for one. The Roman cookbook attributed to Apicius, a collection of recipes likely compiled across the 1st through 5th centuries AD, features honey in desserts, sauces, and preserved meats alike. Refined sugar, derived from sugarcane, would not arrive in Western Europe for another 1,000 years. Until then, honey was not one sweetening option among several. It was the only one. And here is what is remarkable. Across all of this, across India and China and Greece and Rome, across thousands of years and dozens of distinct civilizations, every single one of them noticed the same strange thing. They noticed that honey did not spoil. They noticed it, and they relied on it, and they built traditions around it. But not one of them could explain why. Pause here, because this is the part that gets genuinely strange. We have just traveled through 8,000 years of human history. Cave painters and pharaohs and Indian physicians and Greek philosophers and Roman poets, every single one of them worked with honey. Most of them depended on it. Many of them were among the most sophisticated thinkers their civilizations ever produced. Aristotle catalogued bee colonies with precision that remained influential for centuries. Hippocrates built a medical tradition partly on honey's properties. Egyptian physicians applied it to wounds and tracked its effects case by case. And not one of them, not a single mind across all of that accumulated human intelligence, could explain why honey does not rot. They tried. Greek natural philosophers proposed theories involving the air, the divine, the particular nature of bees as sacred creatures. Medieval Arab physicians who inherited the Greek texts and expanded on them continued using honey therapeutically, but remained unable to describe the mechanism behind its preservation. Everyone accepted the fact that honey lasted. Nobody cracked it. The explanation was sitting in the honey itself the entire time, waiting for someone to ask the right questions with the right tools. And getting those tools would take until the 19th and 20th centuries, until microbiology existed as a discipline, until the concept of water activity was formalized, until researchers could measure pH with precision and observe enzymatic activity under controlled conditions. What is strange is not that ancient scientists failed to solve it. They lacked the instruments, the vocabulary, the conceptual framework of microbiology entirely. What is strange is the scale of the failure. 8,000 years, dozens of independent civilizations, some of the greatest analytical minds in human history, all stumped by a substance sitting on every kitchen shelf. The answer, when it finally came, turned out to be elegant, specific, and built into the honey's chemistry, from the very first drop a bee ever deposited into a wax cell. The reason honey does not spoil comes down to 4 compounding properties, each one formidable on its own, and together forming something close to a perfect antimicrobial fortress. Understanding them requires understanding what bacteria actually need to survive. Like all living things, bacteria need water. Not much, but some. Enough to carry nutrients into their cells and waste products out. Remove the available water below a certain threshold, and bacteria cannot function, cannot reproduce, cannot survive. The first property of honey is that it contains almost no available water. Honey, as a proportion of its weight, is roughly 80% sugars. Its water content in mature honey sits between 15 and 20%, but that figure is misleading because most of that water is chemically bound to the sugar molecules and unavailable to bacteria. What matters is water activity, a measure of how much unbound, biologically accessible water is present. Honey's water activity typically ranges from about 0.5 to 0.65. Most bacteria need water activity above 0.9 to survive. Honey is not merely dry for a food. It is, from a microbiological perspective, essentially a desert. This property alone, this extreme dryness, is doing the majority of the work in a sealed ancient storage vessel. Low water activity is why honey in a sealed jar can survive centuries without refrigeration. The other properties compound on top of it. The second property is acidity. Honey's pH sits between roughly 3.2 and 4.5, an environment hostile to the vast majority of bacteria and pathogens, which evolved to function near a neutral pH of 7. The dominant acid is gluconic acid, produced during honey's formation. For context, that pH range overlaps with orange juice and is more acidic than many fermented foods. Between extreme dryness and acidity, honey has already constructed 2 independent barriers against microbial life. But bees added a third during the honey-making process itself. When bees collect flower nectar, which starts at roughly 80% water, They pass it between workers inside the hive, each one adding digestive enzymes from their salivary glands and fanning their wings to drive off moisture. One of those enzymes is glucose oxidase, and it breaks down glucose in the nectar to produce two byproducts: more gluconic acid, deepening the acidity, and hydrogen peroxide. Yes, the same compound used to disinfect cuts. Honey is quietly and continuously generating its own antiseptic. This chemistry is most active when honey is diluted with fluid, as happens when it is applied to a moist wound, and less prominent in a sealed, dry jar where water activity is already doing the preservation work. But in wound care, the peroxide action is real and clinically documented. This is why those ancient Egyptian wound treatments worked. The physicians applying honey to injuries were delivering a sustained, low-level antiseptic treatment directly to infected tissue. They had no idea that is what they were doing, but the honey did not care whether they understood it or not. It worked in 1500 BC, using the same chemistry it uses today. The fourth property ties the entire system together. Honey is hygroscopic. It actively draws moisture from its surroundings. If a bacterium lands on the surface of honey, the extreme sugar concentration pulls water out of the bacterial cell through osmotic pressure. The bacterium dehydrates and dies on contact, requiring no intervention, no refrigeration, no preservative additive of any kind. Put all four together: low water activity, high acidity, continuous hydrogen peroxide generation when wetted, and osmotic dehydration of any invading microorganism, and you have a substance actively hostile to virtually every form of microbial life on Earth. As long as moisture is not introduced from outside, honey is self-defending. The FAO's Codex Standard for honey permits no food additives in honey for exactly this reason. It does not need any. It is already, in its natural state, essentially indestructible. That is what sits in those sealed vessels pulled from Egyptian burial sites. Not a miracle, not a mystery, a piece of extraordinary evolved chemistry that nobody had the vocabulary to describe until the 20th century, patient as the substance itself, waiting to be understood. There is one exception to everything described above. One condition under which honey's immortality breaks down completely. And knowing the exception matters because it reframes what the ancient world was actually doing when they sealed honey in tombs and jars. The vulnerability is moisture. Introduce enough water into honey, through a wet ingredient, through condensation, through storage in a humid environment without a proper seal, and the water activity rises above the threshold where microbial life becomes possible. The FAO's technical guidance on honey storage notes that the main microbiological storage problem is fermentation, which becomes possible when water content rises and osmophilic yeasts find enough moisture to activate. Honey below approximately 18% moisture has very little probability of fermentation. Above that threshold, the risk increases sharply. This is not a defect or an inconsistency in the chemistry. It is a precise vulnerability with a precise cause, and it was one that the ancient world found a way to manage without ever identifying it by name. This is why the Egyptians sealed their burial jars with such care, using stoppers of clay and linen and wax pressed tight. They did not know they were protecting the honey from moisture ingress. They knew only that sealed honey lasted, and unsealed honey sometimes did not. The practice was correct. The reasoning was intuitive rather than chemical. And here is the point worth taking from all of that. Across 8,000 years of use, from cliff-climbing hunter-gatherers to pharaonic burial rites to Roman apiary management, every culture that worked seriously with honey arrived, by observation alone, at practices that modern food chemistry would endorse. Seal it, keep it dry, store it cool. They did not need the mechanism to get the method right. One additional fact worth stating directly: honey should never be given to children under 12 months of age. The CDC advises this clearly. Honey is the only food proven to cause infant botulism. Clostridium botulinum spores can be present in honey and produce a dangerous neurotoxin in the low-oxygen environment of an infant's immature digestive system. Adult digestive systems handle those spores without difficulty. Infants cannot. That caveat belongs in this story. Consider what that jar on your kitchen counter actually represents. It is a direct connection to a human decision made 8,000 years ago to climb a cliff face into a swarm of angry bees because something on the other side was worth the cost. The same substance that funded ancient economies was prescribed by physicians 2,500 years ago, baffled Aristotle, and inspired Virgil to write an entire book of poetry, is sitting there now, made by the same small insect, doing the same extraordinary chemistry it has been doing for tens of millions of years. The answer to why it lasts, low water activity, high acidity, hydrogen peroxide generation when it meets a wound, osmotic dehydration of anything that lands on it, was always there. Sealed inside every jar, patient as the honey itself. That is what the title promised. That is what the chemistry delivered. Honey is the only food that humans have been eating, valuing, and failing to understand for the entirety of recorded history and well before it. From the cliff faces of prehistoric Spain, to the burial chambers of Egyptian pharaohs, to the laboratories of modern food science, the story of honey is a story about a substance that refused to behave like everything else, and about the species that recognized that refusal and built 8,000 years of civilization partly around it. If something in this history surprised you, subscribe. Next, we go deeper into another food that quietly shaped the world. The question worth sitting with: if honey's immortality was hiding in plain sight for 3,000 years, what other ordinary thing in your kitchen is waiting to be properly understood?